Okay, I want to move back over here. Last class period, we were talking about, among other things, for this introduction to statistical inference, random sampling distributions of means. I said that this was a very important concept for this class. I said that it was a basis, really, for hypothesis testing, and that everyone needed to know how, at least theoretically, we formed a sampling distribution of means. This is not something that's ordinarily done. However, there is a need that you know how the process is supposed to be done. For this example that we did, we had large population scores where the mean was 100, the standard deviation was equal to 10. What we did is selected samples of 25 cases from this population, and we determined the mean for each one of the samples of 25 cases. And after we sampled the 25, we returned those scores back to the population. We repeated the process a very large number of times. What we did is create a sampling distribution of means based upon a sample size of 25. There is a different sampling distribution of means based on a sample size of 30 or a sample size of 20 or a sample size of 50. For this particular sampling distribution, every single sample was based on 25 scores. When we did that, we found that the means were close to what the population mean was, but not exactly equal to. There were some of them that were larger than 100. There were some of them that were smaller than 100. But they were all in the vicinity. I indicated to you that if we determine the mean of all of those means, it should equal the population mean. And because of the fact that we have variability of the means, we can determine the standard deviation of the means of a sampling distribution. And the way that we do that is to divide the population standard deviation by the square root of the sample size. I indicated to you that there was this central limit theorem which allowed us to be able to use information from the normal distribution. This central limit theorem was that the random sampling distribution of means tends toward a normal distribution, irrespective of the shape of the population of observations sampled. And the approximation of the normal distribution becomes increasingly close with increases in sample size. It doesn't matter what the shape of the original distribution happens to be. It can be rectangular, like this. It can be like a pyramid. It can be skewed positively. It can be skewed negatively. If we select samples from those populations, samples of means, and we determine the mean of the means, and we determine what the shape of the distribution of means looks like, it will be normal. It will not look like the original distribution. Rather, it will be normal. And right at the tail end of class, we took a look at that one hypercard example where we generated one of those. Sampling distributions as probability distributions. Random sampling distributions of means may be interpreted as probability distributions. And hence, we may use information regarding the normal curve to determine various kinds of information. And what I would like to do is to look at a couple of different examples of problems that involve sampling distributions of means.